Okay, the chapter for circles is going to involve a lot of vocabulary. So we're going to start this lesson by just introducing the vocabulary, and then we'll get into some of the theorems that go behind it. A circle is a set of all points in a plane, a given distance from the given point. So the point is called the center of the circle, and every point on the circle is going to be the same distance from the center. We usually name the circle by its center. So we would call this circle, circle A. And when you guys write it, you can just write this little circle with the letter. There are a lot of different vocabulary words that come with the parts of a circle. The first one is a segment that joins the center of the circle to a point on the circle. So segment AB, center of the circle to a point on the circle, is called the radius. A segment that joins 2 points on a circle, so FE is a segment that joins 2 points on a circle, is called a chord. When you have a chord that passes through the center, so DC, so a chord that passes through the center of the circle is called a diameter. A line that contains a chord, so this line here contains chord FE that intersects the circle at 2 points, is called a secant. A line that intersects a circle in exactly 1 point, come over here. This line, we'll give this a little g as well, and then we can call it line G. That line is called a tangent. And then finally, an angle whose vertex is the center of the circle. So angle CBA, whose vertex is at the center of the circle, is called a central angle. Central, keyword, center of the circle. Okay, so let's test your vocabulary. Point F, we want to describe it as a center, a chord, a secant, a tangent, a diameter, or a radius. Point F is actually contained in a tangent because point F is the point of tangency. We can call this the point of tangency because it's the point where a line touches a circle at one spot. HG is a center point to the end point on a circle. It's called a radius. Okay, so go ahead and pause the video and try the rest of E through H. Okay, and these are the vocabulary words that you should have put for each letter. Alright, so as we know, a degree is 1 out of 360 of the circular rotation about a point. So each degree is 1 out of 360 possible turns about a point. This means that the sum of the measures of the central angles of a circle is going to be 360 degrees. So here's the central angles in a circle, and centered around that point, those angles are going to have a sum of 360 degrees. Recap the angle of a circle. Each angle of a circle is called a central angle if the angle's vertex is in the center of the circle. The central angle has the center of its circle as its vertex, as I just said, and its sides are contained in 2 radii of the circle. So from the center to the end point, that's one radius. Center to the end point, that's another radius. and plural of radius is radii. So the measure of angle 1, 2, and 3 is going to be 360 degrees. A central angle separates the circle into two parts. Each part is called an arc. So this right here, formed by angle 3, is called an arc. There's three types of arc. There's a minor arc, and a minor arc is formed by a central angle less than 180 degrees. We name it using 2 points of the arc with this symbol above it, AB. So this central angle, which is also the same as the measure of the arc, is less than 180 degrees. A major arc is going to be greater than 180 degrees. And the major arc we would know is a major arc because we use 3 points to name it. So this major arc is greater than 180 degrees. And it's named by 3 points. And then you have a semicircle. And a semicircle is formed when a chord goes to the center of the circle, or a diameter forms a semicircle. So the measure of this arc is 180 degrees exactly, or the measure of this central angle is 180 degrees exactly. Okay, so to find each measure in this circle, we have the idea that our centered around any point is 360 degrees. And we also have a diameter here, which will be very helpful for finding missing angle measures. So before we answer any one of these questions or find any one of these angle measures, we're going to just look for them without being prompted. This is 45 degrees. RCS is 45 degrees. TCU is 60 degrees. And we don't know this angle right here. But if you notice, this is the diameter of the circle. So it represents half of the circle, 180 degrees, or a straight line, which has an angle measure of 180 degrees. So of that 180 degrees, we already used 45, and that would give us 135. And we've already used 60, so that would give us 75. And that's what this angle measure is here. Then we look at the other half of the circle. Well, they told us that these two angles together are 90 degrees. If one of them is 45, then this one is 45. And here's our other semicircle. So this equals 180 degrees. So we would just take 180 and subtract this 45 that's already been used. So this entire angle measure here is 135 degrees. So the measure of SCT, S to C to T, is 75. SCQ is 45 plus 45, which is already marked as 90 here. SCU is this entire angle, 75 plus 60, which is going to give me 135. And then QCT, which is from here to here. So it's 135 plus 60, which is a total of 195. Okay, 5 through 10, they give us angle BOA. BOA is 44 degrees. And we want to find the measure of each arc. Well, the measure of an arc is the same as the central angle. Central angle is the same. So if this central angle is 44, then this arc is 44 degrees. So arc BA, the first question, is 44 degrees, the same as the measure of its central angle. Now in order to figure out the rest of the arcs, I'm going to have to figure out the rest of the central angles. So here I have vertical angles, and they're congruent. And then I have a linear pair, These two angles form a linear pair. So I have 180 minus 44, so that makes this angle 136. And then once again I have vertical angles, so that angle is 136. So now I would like for you to pause the video and find the arc measures for the following 7 through 10 and see if you get what I get. Okay, and these are the angle measures that you should have gotten, or the arc measures that you should have gotten. So basically just remember that the central angle is the same as the arc. Central, same. They kind of sound the same. They have the same beginning sound. Central, same. Central, same. Alright, so go ahead and start video number 2. We'll talk about inscribed angles. They're not exactly the same as central angles. They are in fact angles, but they're not the same. So go on to video number